solving this thing? What should we do from here? What kind of format is this equation in? Yeah, Brian?
Like quadratic.
Yes, exactly. So we should factor this thing like it's a quadratic. Okay? So, Brian, can you see how it's going to factor? We need two numbers that multiply to make what?
3.
Oh. We're going to add to make 3.
Yeah.
And we're going to multiply to make 4.
Alright.
Okay, so what are those two numbers going to be? If I'm putting you on the spot.
4 and -1.
Yeah, 4 and -1. So we'll have sine of x plus 4 sine of x minus 1. Okay? And if you need to, you can check to see, you know, if this will this FOIL back together to give us sine squared x plus 3 sine x plus -4 or minus 4? Yes, right? Sine squared first, outer is -1, inner is plus 4, so it's plus 3, and then last is -4. Okay? So, now that we have this, we factor it, what can we do from here? And what should we do? Yeah, Gene?
Set each one to 0 and solve for x.
Yes, exactly right. Okay, the idea here, right, is that we have a zero product property application, right? Two things are multiplying to give us 0. So that means one of those two things has to be 0. And then we solve. Okay, so you get sine of x equals -4 and sine of x equals 1. Okay? And then we just think to ourselves, okay, now we want to figure out for what values of x, when you take the sine of it, do you get -4? So when does sine of x equal -4? For what values of x? Good answer! Never. Okay, that's right. Okay. When does sine of x equal +1? Okay. So this is where using the reference triangles kind of fails us, because sine of none of these angles will give us 1. Okay. For what? So that means it's got to be an angle that's on like one of the axes. Okay, either the y-axis or the x-axis. So for what angle does sine of that angle equal +1? What is it? Pi halves, or pi over 2. Exactly right. Okay, so the reference triangle strategy kind of fails here because we can't get 1. But bless you, it's on the coordinate plane. Okay, and again, since we're only solving for 0 to 2 pi, that's the only solution. We're done. Okay, so that's it. Questions on any of that? No questions? Okay, let's continue then. Okay. How about this one? Again, same directions. We'll solve for 0 to 2 pi. Okay, and then here is our equation. Tangent of x times sine squared of x minus tangent x sine x minus 2 tangent x equals 0. So, ideas here. How should we maybe proceed? Yeah, James?
Should we start by combining tan of x and 2 tan of x?
Okay, so we could, but this is not just tangent, it's tangent x sine x minus 2 tangent x. So they're not quite like terms, right? Not quite like terms. So good thinking, but yeah, not quite like terms there. Yeah, Brian?
Factor out a tangent.
Yeah, we got a GCF here. Factor out that GCF, and this thing is equal to 0. So take out a tangent of x. What's going to be left behind, Brian, when we do that?
What's going to be left behind?
Yeah, so I take out the tangent x, and then what's still in the parentheses?
Sine squared x.
Uh-huh.
Minus sine of x.
Uh-huh.
Minus 2.
Minus 2. Okay, great. And now at this point, you can kind of go kind of one of two ways. They're both very similar paths to take here, but at this point, since we have two things that multiply to make 0, you can go ahead and break this up if you want to and just say tangent of x equals 0, and then sine squared x minus sine of x minus 2 equals 0. So that's one path you could take. Or you could continue to factor that sine squared minus sine x minus 2, and then at least you'll have three factors, and then set all three of those factors equal to 0. It's going to end up being the same thing, but it's just however you want to, go from there. Okay. However you want to go from there. All right. So let's continue factoring the sine here. Okay. So let's see. Well, we know we're going to have a sine of x and a sine of x. And we're going to need two numbers that multiply to -2 but add to make -1. So -2 and +1. Okay. And so we can say that sine of x is going to equal 2, or sine of x will equal -1. Okay. We'll come back to the tangent in just a second. Let's talk about these though. Sine of x equals 2. When does sine of x equal 2? Never. Oh, good. I got some words there. That was nice. Okay. All right. Sine of x equals -1. When does sine of x equal -1? 3 pi over 2. 3 pi over 2. Uh-huh. Okay. And again, that's fine. I appreciate you guys volunteering something like that. It's tough. There's lots of different angles we have to be responsible for. But yes, it's 3 pi over 2. Now let's go back to tangent of x equals 0. Again, if we go to try and do tangent on these reference triangles, it's not going to help, because there's no way we get tangent, bless you, equal to 0 with these reference triangles. And we have to go to our quadrant, or not our quadrant, our axes, and angles that are on the axes there. Okay? So, if you struggle with thinking about tangent, especially when you don't have the reference triangles, remember the tangent is the same thing as what over what? Oh, maybe I didn't emphasize this enough. Sine over cosine. Tangent is the same thing as sine of x over cosine of x. Okay? Which then, if we think about it this way, sine x over cosine x, for that to be 0, what's the only thing that needs to be 0 then? For sine of x over cosine x to be 0, what's the only thing that needs to be 0? The numerator. Yeah, sine of x. We don't care about, cosine x, it can be 0 at some point, right? That's not what we want, though. It'll make us undefined. We just want to worry about when sine of x is 0. So, really, we need to think about when is sine of x 0. And when is that the case? 0 and pi. There it is. 3 solutions. 0, pi, and 3 pi over 2. But we also need to check to make... Oh, go ahead. Question?
Oh, is 2 pi not a solution because you don't include this?
Yeah,
Okay.
exactly. Yeah. But we also need to check for extraneous solutions, too.
Wait, why isn't that a solution?
Say what now?
Why is
2
2
pi?
pi?
Because
Why
if you
not?
look here,
Never mind.
solve for 0 to 2 pi. We're not including 2 pi. Yeah, Julia, question? No, just stretching. Okay. So, all right. So 3 pi over 2. If we were to plug that back in, okay, if we were to plug 3 pi over 2 back in, what is the tangent of 3 pi over 2? Undefined. Which would then make us not equal to 0. So we actually need to throw out this solution too. So you do need to check for extraneous solutions as well. Okay, so not only necessary for you, in a situation like this where I'm just asking you to solve, you don't have to give this little explanation. You can just, get rid of it. That's fine. Should I ask you to be able to explain it, that's what I would want you to be able to say, though, something like that. So really, it's just 0 and pi there, just 0 and pi. Those work, no problem. Okay. Questions on any of that? Okay. So then let's jump into one other thing here. Then I have to show you. Okay. So, and we'll do some, a couple of these too. Yeah. Okay. So, solve again for I don't know. I guess I'll say solve for 0 to 2 pi. so we'll change this up a little bit and say cosine of 3 theta equals 1/2. Okay, so now it gets a little bit weird because that 3 we have it's inside the cosine there. Okay, so it's cosine of 3 theta. So what we can't do, we can't like divide both sides by 3 here. Well, I'm sorry, we could divide both sides by 3, but it wouldn't cancel out the 3 in front of the theta there because this whole quantity is inside the cosine. We can't get to it. If we divided both sides by 3, we would have 1/3 cosine 3 theta equals 1/6. So that would really be helpful here. Okay. So instead, what I like to do is kind of like do a little bit of like a change of variable and change this problem. So I'm going to say like let's let u equal 3 theta here. So I'm just going to change the problem so we have cosine of u equals 1/2. Okay, just to kind of help us out a little bit, and then I'll show you. Remember, what does that 3 in front of our variable there inside do? Do you guys remember what transformation occurs with that 3? How does that affect our graph somewhat? Any ideas? What does it do? Oh, James, what are you saying?
The horizontal, I forget the name.
So there is if something happens horizontal here, yes, the period in this case is going to shrink. It shrinks the period, okay? It's not going to shift it left or right. If it was shifting left or right, it would have like a plus or minus after the theta there. But that 3 in front, it changed our period, right? Normally cosine goes from 0 to 2 pi. With this 3 theta in there, that would shrink the period by a factor of 3. So instead of 0 to 2 pi, it would go from 0 to 2 pi over 3. Okay, difference there. So it's going to shrink our period, which means our typical solutions for cosine are going to be shrunk down by a factor of 3 as well. So this is how we can kind of account for that, though. So we'll solve this equation. So when does cosine of an angle equal 1/2? For what angles? For what angles theta there? Or u, I should say, sorry. Well, we can go up to here. Cosine is adjacent, so pi over 3 adjacent 1 over hypotenuse 2. So pi over 3 is going to be a solution. Cosine is also positive in the 4th quadrant. So it would be the pi over 3 in the 4th quadrant, which is 5 pi over 3. Thank you. Okay. Which means then those are our solutions for u, but of course we want the solutions for theta, the original, variable here. So we're just going to resubstitute in that 3 theta. Okay, so we resubstitute that theta for u, or 3 theta, I guess I should say. 3 theta for u, sorry. And now we solve this equation. 3 theta equals pi over 3 times and 5 pi over 3, so what should we do to solve for theta? Three times theta equals pi over 3 and 5 pi over 3. How should we solve for theta here? How can we get rid of this 3? What do we do? Yep. Yeah, divide. So we can divide all these by 3. So those cancel. Pi over 3 divided by 3 is pi over 9. 5 pi over 3 is 5 pi over 9. And then here's where it gets a little bit tricky. Because we were trying to solve for 0 to 2 pi, all the solutions that are between 0 and 2 pi, so, these two solutions here, we may have more solutions because we shrunk those numbers down, where we did pi over 9 and then 5 pi over 9. But we could, remember, add 2k pi here, where k again is an integer, or n is an integer, whatever you want to say, 2n pi sometimes. We'll divide that by 3 as well. So once again, right, if we were if we were solving back in like these other problems that we've been doing, pi over 3 and 5 pi over 3 would be our only solutions. But then once we shrink that period down to pi over 9 and 5 pi over 9, okay, we could potentially have more solutions from that shrinking that still fit between 0 and 2 pi. Okay, so we're going to add this 2k pi over 3. Again, it was 2k pi. Normally, we just keep adding 2 pi, but because our period shrinks down, we're going to divide by 3, so it's really 2 pi over 3. And so can I add 2 pi over 3 to this and still be between 0 and 2 pi? Or in other words, instead of 2 pi over 3, we could also say 6 pi over 9. Or 6k pi over, 6 pi k over 9. What do you want to say there? Okay. So could I add 6 pi over 9 to this and still be between 0 and 2 pi? Yes. So 7 pi over 9, right? Because adding 6 pi to that would be 7 pi over 9. Can I add 6 pi to this? Yes. 11 pi over 9 would still be between 0 and 2 pi. Could I add another 6 pi to this? 6 pi over 9 to this? Yes. 13 pi over 9 still fits between 0 and 2 pi there. Could I add 6 pi to this? Yes. 17 pi over 9. And now we're done. Because if I add another 6 pi over 9 to this, it would be 19 pi over 9, and that is 18 pi over 9. Add another 6 to that, it would be 23 pi over 9. So those are all the possible solutions. Okay. So these are our primary solutions, right? And then we added the 2 pi over 3, 2 pi over 3, and so on and so forth. Okay. Keep adding the 2 pi over 3 there. That's the idea. Okay. So let's take a look at another one. Let's try another one here. Question, Sean.
You said you were adding 6 pi over 9, but 11 and 13 only make 2 apart.
Right. But where did I get the 13 from? I got the 13 not from adding 6 pi over 9 to this one, from adding 6 pi over 9 to this one. Since we had these two initial kind of like initial solutions or like root solutions, so it's really like this one, then plus 6 pi over 9, and then plus 6 pi over 9 here, and then this one plus 6 pi over 9 plus 6 pi over 9.
Okay.
Yeah. Maybe my arrows didn't do a very good job. Let me try and be more careful. Like that, and then like that, and they kind of skip each other. Thank you for asking that, though. Okay. Try another one here. Okay. And this one, I'm just going to say solve for x. Okay, bless you. So I'm not going to specify, find all the solutions between 0 and 2 pi here. Okay, I did that for this one, but you don't always have to do that. Sometimes you just have to solve for x, in which case you don't need to come up with all these other solutions. You can just come up with like the initial ones and be done. Okay, and this will be our last one here, so you guys get some chances to get started on the assignment and stuff too. Okay, so 3 tangent of x over 2 plus 3 equals 0. 3 tangent x over 2 plus 3 equals 0. Okay. Is that plus 3 inside the tangent or outside the tangent? Outside, right. When you see addition, okay, it will be in parentheses if it's inside. So it's outside. Okay, so how should we go about solving this? What should we do? First step. Anybody? Subtract 3. That's right. Okay, and then? Divide by 3, yeah. Equals -1. Again, tangent of x over 2 equals -1. I'm going to say let's let u equal x over 2, just kind of make it more friendly. Okay, let u equal x over 2 there, so there's that. And so then when, or you could say let theta equal x over 2, whichever one you want to use there. Oops, why am I saying that? Sorry. So tangent of u equals -1. Tangent, when does tangent equal a -1? Well, we can get tangent to be +1 at pi over 4, right? Tangent of pi over 4 is 1 over 1, opposite over adjacent. But we need to be -1. So what pi over 4s are we talking about here? Not in the first quadrant. Second quadrant, so 3 pi over 4. Not in the third quadrant, because tangent's positive in the third quadrant. Fourth quadrant though, 7 pi over 4. Okay. Then we resubstitute in that x over 2. And in this case, to solve for x, what should we do to both sides? Multiply by 2. So you get x equals 3 pi over 2 and 7 pi over 2 when you multiply both sides by 2. Okay, and then those are your solutions. Okay. In this case, bless you, in this case, if I was asking to solve only between 0 and 2 pi, so again, in this case, if I was asking to only solve between 0 and 2 pi, what would be the solutions then? If I was only asking us to solve between 0 and 2 pi, what would be the solutions then? Just the 3 pi over 2, yeah. Just the 3 pi over 2. 7 pi over 2 is outside, so it would only be one solution in this case. And that's because our period stretched this time. Okay, when it's dividing by 2 in there, you stretch by a factor of 2. So, all right, let me get you guys started on your assignment here. So you get some time to, get some practice in. All right. All right. So page 394, numbers 33, 39 to 43, 63, and 91. And those are all the odds there. So any odds. Okay.
1, 2, 3, 4, 5.
Is that still too many? Yeah, not our way. Okay. So there it is. Okay. And of course, to finish up any of the previous assignments that you did not finish as well. And if you had trouble, please, ask me questions. We can go over stuff too. Okay.
Water. How original. Good. The sun should rise. Yeah. Let's play filler. Pretty straightforward. No.
We started last time with 1.
I started by the time you like he has an actual iPhone, I don't know, iPhone 4. Didn't he use the 4 when we went to Canada this summer? SOS.
She's making it cookies. He kept pushing and now it's touching.
What is that?
They're big